Okay, so now 10.4, we're looking at kind of a different scenario for our testing. Let's look at this example. A study is conducted to investigate the effectiveness of hypnotism in reducing pain. The results for randomly selected subjects are shown in the table before. A lower score indicates less pain. The before value is matched with an after value, and the differences are calculated. The differences have a normal distribution. Are the sensory measurements on average lower after hypnotism? Okay, so what we want to notice here is that we have only one population. We have a population of people that are having some pain. And from each, and then we take a sample from that population, right? We have a sample of 8 here. For each of those sample members, we have 2 measurements. Okay, so like for subject A, we have the before measurement of 6.6 and the after measurement of 6.8. Okay, so they come from the same sample member, but they're 2 different measurements. Okay, so here, this is where we don't have independent samples, right? We have one sample that we're getting 2 measurements from, and from this, we want to compare means from those 2 measurements. Okay, so what we're actually going to do a test on, though, is the difference between one measurement and the next for individual members of the population or sample. So this test, it compares 2 measurements from each member of one population and is a test about the mean difference in the pairs of values. Okay, so this mean difference, it's the mean of the difference values that we're going to calculate here. So we can kind of think of that as D. D equals the difference for one particular sample member. Okay, so what we're actually testing about, the parameter that we're testing is mu sub D. All right, that true population difference, or that true difference between the before and after. And then we estimate it with X bar. So X bar sub D, that is going to be the mean of the differences that we calculate. All right, and then we calculate the standard deviation of those differences, and that's S sub D. Okay, just a little bit of other background. So this is requiring simple random sampling. Sample sizes are usually small. We take 2 measurements from the same individuals or objects, and we calculate the differences for each member. And the differences form the sample that's actually used for the hypothesis test. And we use T for the distribution. Okay, let's calculate the differences for our sample members here. So for subject A, we're taking before and then minus the after. So we get 0.6 minus 0.8, we're actually going to negative 0.2. For B, taking that difference, 4.1. And for C, 1.6. For D, 1.8. For E, 3.2. For F, 2.0. For G, 2.9. And H is 9.6. Okay, so we want to keep in mind that a lower score means less pain. So that means that a positive number here means a decrease in pain, okay, because we're going from higher pain, a higher number, to a lower number, lower pain. Okay, so those are the individual differences. Now we can calculate the mean of those differences, and that's going to be the X bar D, and that is the value 3.13, and the standard deviation is 2.91. Okay, so that is taking the mean of those differences and the standard deviation of those differences. Let's look at the steps, the difference in the hypotheses, to start off with. The null is always that this mean difference is 0. Okay, it's always that. And then we have three options. Either the mean difference is greater than 0, it's less than 0, or it's not equal to 0. Okay, then the step 2, the test statistic is also different. We're going to take the sample mean difference over the sample standard deviation of the differences over the square root of the sample size. And when we calculate the p-value, it's just a simple degrees of freedom, looking up the value with the online t-distribution tool. Okay, so let's run through this example. We want to test at a 1% 1% significance level, and we want to answer the question, are the sensory measurements on average lower after hypnotism? So our null hypothesis is that the mean difference is equal to 0. And the alternate, so if they're lower, that means that the mean difference is positive. Okay, because a lower score is a lower pain. So if that the value is positive, that means that there's been a decrease in pain. All right, now we can calculate the test statistic. So it's a t-value. We calculated that sample mean difference is 3.13. And the standard deviation is 2.91. And our sample size is 8. That gives us a test statistic of 3.04. And we have a pretty straightforward looking up of a p-value. Our degrees of freedom is 7. And we've got a right-tailed test. Okay, so finding that value using the calculator online, it is 0.0094. So our conclusion is we are going to reject the null, that there's no difference in pain, and that's because our p-value is less than our significance level of 1%. Okay. All right, so we're rejecting that there's no difference in pain before and after the treatment.